Agwinusha Korja. My name is Paul Cunningham and welcome back to day 3 of IST-Africa 2022. This is the first next generation computing session with presentations from South Africa, Uganda and Zimbabwe. And we're going to start with a presentation towards developing a broadband infrastructure dashboard framework.
Good day, ladies and gentlemen. My name is Nosipho Mthethwa from the CSIR in South Africa. Today, I will be presenting you a paper titled Towards Developing a Broadband Infrastructure Dashboard Framework. This is the outline for my presentation. I will start with the introduction, then motivation and problem area, research objectives, research methodology, framework, benefits of having broadband mapping dashboard, then show you an existing dashboard and conclude my presentation. Broadband mapping is when the deployment, coverage, and quality of broadband are collected and presented for a geographical area. Broadband mapping can be differentiated into 4 different categories, namely broadband service mapping, broadband infrastructure mapping, broadband demand mapping, and broadband investment and funding mapping. Broadband service mapping is the presentation of broadband service operators, available bandwidth, and the quality of service provided. Broadband infrastructure mapping is defined as the visualization of the detailed deployment of broadband infrastructures for a geographical area and other infrastructures constructed that is suitable for hosting broadband networks. Broadband demand mapping focuses on gathering information on the demand of broadband services, including the required speed and the user's willingness to pay. Broadband investment and funding mapping gathers, consolidates, processes, and visualizes information related to financing sources and instruments for broadband project funding. For this research, focus was placed on broadband infrastructure mapping. The broadband infrastructure focused on is fiber, mobile broadband, which include 4G, LTE, and 5G. Wi-Fi and TV white space are also noted, but ADSL, VDSL, and satellite are broadband infrastructure that were not considered for this research. This research was motivated by the unavailability of a centralized system that shows broadband infrastructure that has been deployed. The system will show the connectivity layout by converging the coverage maps from all participating broadband providers and will thus extend the penetration of broadband infrastructure in developing and underdeveloped countries. The objective of this research was to use an ICT system to facilitate a process that informs user needs while enhancing the decision-making process. This was done by investigating existing broadband maps internationally and locally, and the development of a broadband infrastructure dashboard, which can be used to present in a much structured way a platform that can showcase the availability and characteristics of available broadband infrastructure in a geographic area. The methodology adopted for this project was the methodology of developing a conceptual framework. The guidelines for this methodology are to perform literature review or research, identify and isolate important variables, and develop your framework using the identified variables. The identified variables for this project were human resources required, data, which involves data collection mechanism, data formats, data processing, and data storage and security. Software used to implement the dashboard, and hardware resources and infrastructure. To conceptualize the proposed broadband infrastructure mapping, 3 frameworks have been identified for this study, namely the Interoperability Framework, the Readiness Framework, and the Usability Framework. The Readiness Framework speaks to the state of a system and its ability to change. To adapt to change, the system needs to be flexible enough to internalize change and allow transformation to a new state. The interoperability framework is a crucial element to consider in a context where systems need to exchange data or in any data pull or push situation. Due to different systems storing and processing data in different ways, an interoperability platform helps with repackaging the information into a particular set format and standard for ease of analysis and processing. This would be a crucial platform for the backbone of the broadband dashboard system, as it will receive different data packages from different suppliers, product owners, and any other data received through the data mining process. Interoperability for this exercise includes data collection and processing, storage, and security. Usability is defined as the extent to which a product can be used by specified users to achieve specific goals with effectiveness, efficiency, and satisfaction in a specified context of use. The usability framework describes the user's activities and experience when the user interacts with the computer or any system. The usability framework is usually based on existing knowledge, empirical studies, and information visualization effectiveness. Facilitates sustained change, enrolls stakeholders, manage, adopt, and influence change, developing capacity and managing the system operations are readiness aspects that need to be addressed. This ensures that all stakeholders are identified and the vision is clearly communicated with them. The identification of who will oversee and ensure that all institutions deliver what the project expects of them at different levels is also addressed by these. Non-compliance and lack of commitment are also addressed in this framework. The readiness framework also makes it clear to all stakeholders when and how often project details are communicated. It is important to clarify who the stakeholders should contact and or communicate with when needed. Political climate, community engagement, and funding strategies are also covered in this framework. Interoperability framework categories are data, security and storage, and human resources. Broadband providers already have their data saved in their preferred data file types. This means that data will be available. However, it will have to be converted to a uniform data file type. This conversion of data should not be the task of broadband providers, as this will require a lot of efforts from them and will discourage them from participating. A medium should be created where data will be received and converted to the desired data file type. Broadband providers can share the required data through email, upload to a server or portal, data entry on a web portal, or web services. The data provided by broadband providers should be stored securely. This data can be stored on a server, a NAS, a web server, or cloud services. The server and NAS can be easily corrupted if safety precautions are not taken, and the web server needs to be connected to service level agreements for smooth operations. The server and NAS have fixed storages, while cloud services storage is easily scalable to the amount of data available. It is important to ensure that the data shared by broadband providers is also secured. The use of software and hardware firewalls will ensure that the data is secured. The human resources required for this project is an administrator, a software developer, a GIS specialist, and a telecommunications specialist. Usability has two spheres, which are the system or product and the usability measures. When a system is designed, the developers should consider the user, task, equipment, and the environment. It should be ensured that the system meets the needs of the user while fulfilling the designer's interests. The system needs to be able to perform the task it was designed for. The equipment or technology and environment should be user-friendly and easy to navigate. The usability of a system is measured by effectiveness, efficiency, and satisfaction. Effectiveness measures the extent that the user can achieve a goal with accuracy and completeness. Efficiency measures the level of effort and resource usage which is required by user to achieve a goal in relation to accuracy and completeness. Satisfaction is the positive association and absence of discontent that the user experiences during the performance. The benefits of having a broadband infrastructure mapping dashboard are aiding in the deployment of broadband infrastructure, especially in developing and underdeveloped countries. Indicate areas that still have outdated broadband infrastructure. Avoid redundancy of infrastructure deployment and to provide accurate statistics to ITU. This is an image of an existing broadband map dashboard from New Zealand. The user will be able to put in the address and it will be pinged on the map on the right. This is a legend where the user will choose the type of broadband technology they want to see, and on the left is where the available broadband technologies will be shown to the user. In conclusion, the three identified frameworks, which are the Readiness Framework, the Interoperability Framework, and Usability Framework, contribute to the bigger framework of developing a broadband infrastructure mapping framework. Broadband infrastructure mapping will benefit developing countries as it will promote infrastructure deployment and decrease the internet connectivity gap. The outlook includes researching the role of 4IR in advancing broadband infrastructure mapping, the social and business benefits in having broadband infrastructure mapping available, and technology platforms for broadcasting information on existing broadband infrastructure. Thank you.
Thanks very much, Nosipho. Can you talk us through what alternative broadband mapping solutions are currently used in an African context? And what do you perceive as some of the challenges or potential barriers to broader adoption of your proposed approach in an African context? Thanks.
I'm sorry, can you please repeat the question?
Of course. Can you summarize some of the alternative broadband mapping solutions already in use in an African context? And what are some of the opportunities, challenges and barriers to broader adoption of your proposed approach in an African context?
Oh, okay. So I searched specifically in South Africa. So currently there are various broadband maps, but they are just for that certain company that is providing the broadband. So in this case, we just wanted a centralized map dashboard that is going to have the information from all of the broadband providers. Right now, one of the precautions that we would have to consider is signing NDAs to make sure that the companies feel free to share information with us, and that we are not going to distribute their information to their competition and other people that they wouldn't be comfortable sharing their information with. And it is also the problem of the speed, because it cannot be accurately measured. That is why we are not focusing on service mapping at this point in time. We're just mainly focusing on we're mainly focusing on infrastructure. Another problem would be the crime in Africa. So it would be the risk of having your information about your fiber lines out there, and people have access to that information and they may commit some crimes. Yes.
So if I take a counterpoint to your argument, I think the issues you've raised are legitimate, but looking at it from a devil's advocate perspective, one key stakeholder that could enforce sharing of such maps would be the regulator. Something else to consider in your research is that one of the challenges that has been experienced across Europe is lack of visibility and transparency about where fiber optics and things like that have been laid. So now most metropolitan areas have rules in place, which means that that information has to be shared publicly. And the reason that's very simple. If people need to do digging in their garden at home, or if somebody's doing construction on a construction site, if they don't know that fiber is laid, for example, or equally with electricity or gas or whatever it might be, they could potentially disrupt those services. So having that information publicly available is a public safety issue as much as anything else. So I wonder if you have any thoughts on those issues in terms of the role of the regulator and also the public safety issues related to making such information transparently available.
Okay, yeah, that's true, especially with the public safety. When we started this research, it was because we would see diggings like all the time, and sometimes people would be digging and they would find fiber lines already in that area that they wanted to deploy their fiber. So that is also one of the reasons that we would want to have this information out there.
Yeah, and I'm sure the regulator would support that. Another issue for you to consider is the concept of shared services. In other words, it costs a lot to lay fiber. So if fiber has been laid and if it's publicly known where that fiber has been laid, the regulator can insist that there is sufficient dark capacity available that can be taken up by other vendors in the future. And then in return, and the person or the organization that laid the fiber in the first case or put the channels in place to facilitate laying additional fiber later can be somehow compensated for that infrastructure investment. Again, if you think of it from a mobile antenna point of view, it has become very common now to use the same transponder points to share multiple vendors and transponders rather than having the eyesore and the extra cost of putting multiple poles simply to have another transponder for another vendor. Again, just something to think about.
Yeah, that's very true. Thank you.
Right. If there are no other questions or comments for Nosipho, thank you very much indeed. And we then move on to a presentation from Uganda, which is about the development of an interactive remote iLab for a wind energy system.
Greetings to all of you who are attending this presentation. My name is Yusuf Kyambadde from Makerere University here in Kampala, Uganda. I am a computer engineer, a researcher, and a teacher. I would like to present to you my research, which is titled Development of an Interactive Remote iLab for a Wind Energy System. The motivation behind the research. It is a well-known fact that engineers acquire practical knowledge and skills during training through educational labs. However, These labs tend to be, one, very costly to purchase and later on maintain, and two, difficult to provide for every learner because they are very expensive and at times require a lot of space. And finally, this problem is compounded when learning institutions enroll very many learners on engineering programs than the available laboratory equipment can accommodate. As can be seen in this picture here, we have a group of learners crowding around a single set of laboratory equipment, and in circumstances like this, one or two learners will actually carry out the experiment and the rest will be reduced to mere spectators, as can be seen about some of the learners here. So in circumstances like this, learning cannot take place equally for all the learners. So when I scanned the learning environment at my parent institution, which is Makerere University, and also at the University of Technology and Arts of Byumba in Rwanda, I discovered that these issues are so prevalent in nearly all engineering programs. But I also discovered that the problem was worse for the renewable energy program at the University of Technology and Arts of Byumba in Rwanda, and for the wind energy courses at Makerere University, which is why I took the initiative to develop this remote wind energy laboratory, which can be used for studies about wind energy systems and can be shared between learners at Makerere University and learners at the University of Technology and Arts of Byumba in Rwanda. The objectives of the research. The main objective of the research was to develop a wind energy remote laboratory that will complement the theory and enhance learning about wind energy systems. The specific objectives were, one, to determine the requirements for an interactive wind energy remote laboratory. Two, to design a wind turbine system and a laboratory user interface. And three, to develop a data acquisition system and an electrical circuit to interface it with an Arduino microcontroller. And lastly, to set up the remote wind energy laboratory so that it can be accessed remotely via web server. The approach to the research. First, a review of the curricula for the renewable energy program at the University of Technology and Arts of Byumba in Rwanda and for wind energy courses at Makerere University was done. And in this review, the requirements for a remote wind energy laboratory were established. After that, prototyping of the physical part of the laboratory was done. And here, an electrical circuit was prototyped, was designed and tested. And after that, programming was carried out. And here, the user interface of the laboratory was designed and tested using LabVIEW version 18.0. The same software was used to program the NI Elvis board on which the designed electrical circuit was installed. Also, the Arduino microcontroller was programmed by writing code through the Arduino IDE. For data acquisition, several sensors were used. Specifically, a DHT11 sensor was used to acquire data about temperature and humidity. A wind speed sensor was used to acquire data about wind speed, and then an NI MIDAC was used to acquire data about the number of revolutions per minute for the wind turbine. Then finally, experimentation was carried out, and here sample results were generated and were compared with the results from physical wind energy experiments and also compared with the results from other researchers. So the laboratory setup looked like this. It was set up using a desktop wind fan, which can be seen here, a wind speed sensor, which can be seen here, and a miniature wind turbine, which can be seen here. And then the electrical circuit designed was installed on an NILV's prototyping board, which can be seen here. The user interface looked like this with several tabs. This is the welcome tab, which introduces the remote experimenter to the laboratory and also gives the experimenter some brief information about the experiment that they are yet to conduct. The second tab is where the experimenter remotely controls the physical equipment by setting values for some parameters and then observe change in the other variables. On the second tab is where the temperature and humidity are recorded and graphs plotted. On the fourth tab is where the turbine voltage and wind speed are recorded. On the second last tab is where we have wind power analysis. And then on the last tab is where the wind power curve is plotted. In generating sample results, it was observed that very high and very low pitch angles required very high wind speeds to generate significant power. So for purposes of generating optimal power, pitch angles of 25 degrees and 45 degrees were used in this study. And this table shows results that were generated for a pitch angle of 45 degrees. And here, 3 blade specifications were used. That is custom 28, NAC 44, and NAC 63. For each of these blade specifications, 3 speed settings were used. That is low, medium, and high. These are the results that were generated about wind speed, temperature, humidity, turbine voltage, and power generated. The table here shows results that were obtained from a physical wind experiment, and these were compared with results generated from a remote laboratory. In discussion, after generating sample results, a plot of power generated against wind speeds produced a curve which was nearly similar in shape to the non-theoretical wind power curve, which provided proof that our designed remote wind energy lab was working correctly. 3 blades were used in this research because this is the recommended number for optimal power generation, as can be found in studies of Mukule et al. Of 2016 and Cantelo and Y of 2018. The pitch angle greatly affected the turbine speed and consequently the power generated. Very low and very high pitch angles required very high wind speeds to generate significant power. For better experimental results in this study, pitch angles of 25 degrees and 45 degrees were used. Experimental results that were generated were compared with those from a physical wind experiment and those from other studies, and were observed to be in range, which again provided proof that our designed remote laboratory was working correctly. In conclusion, due to the low funding for engineering education, this very cheap remote wind energy lab can be used to supplement, complement, or even replace the very expensive hands-on wind labs. The lab enables learners to measure the many variables about a wind energy system, such as temperature, humidity, wind speed, to mention but a few. The advantage that this lab has is that it can be accessed by instructors and students at any time. So this will enable them to overcome the strict timetabling in their institutions of learning. The lab also proves that it is possible to create a rich pool of remotely accessible labs that can be shared amongst students and amongst universities through collaboration. For future work, the pitch angle in this lab will be automated by designing a robotic module which can alter the pitch angle, which can be used to alter the pitch angle remotely. I would like to thank DAD and Mapronani S for providing funds that were used to develop this laboratory. And I would also like to thank everyone who has taken time off to listen to my presentation. I welcome all your feedback. Thank you very much.
Thanks, Yusuf, for this interesting presentation. So before I open up to anybody else, can you talk about the characteristics of the 3 different blade specifications that you mentioned that were tested and why each will be used in specific contexts?
Thank you for the question, but can you repeat?
Of course. On one of your earlier slides, you described 3 distinct types of blade specifications that were tested. I'd like you to briefly explain to the audience the characteristics of each and why each will be used in specific contexts.
I used a Minish wind turbine as I've explained in my presentation. The blades of the wind turbine had a length of about 15 centimeters, and the base of the wind turbine was about 15 centimeters. So the blade area, swept area of the entire blade system was about 32 centimeters. So which was enough to generate significant power, which could be captured and recorded by the system.
And could you share some insight into the hardware costs and the maintenance costs of such an infrastructure?
The lab is mainly administered by a single administrator. So when you compare this one to the actual physical lab, you can see this one can be very cheap. It didn't cost a lot, just about costing to purchase the wind turbine and then the Arduino module, and maybe the most expensive hardware that were used were the NI LVS prototyping board. For future labs, this one can be improved to a better version, and then maybe the license for the software, which is LabVIEW. So which is not quite expensive compared to purchasing the physical hardware.
Okay, Alex, you have a question.
Yeah, hello, Mr. Yusuf.
Hello.
Yeah, I just want to know what is the level of energy generated by the system. I know it's for training purpose, and that is one. How much, let's say, watts does the system generate, and how can we compare with the real systems, taking into consideration the dimensions of the turbines and other components that have been used to create the system, so that our students can be in a better position to understand that in the real world, this is how the system will perform if the dimensions will be increased at this ratio, but at the lab settings, this is how the system work and the amount of energy generated. How can we compare those two? Thank you.
Like you have correctly said, the system is used basically for study purposes, and
Yes.
it can generate power in watts in the range of 0.065 to 0.012 watts. So,
okay.
But of course, the amount of power generated can be increased.
Mm-hmm.
Can be increased maybe by varying the number of blades on the turbine, or by increasing the wind speed. Those values can be altered. The experimenter can explore how much power will be varied by altering some of those parameters.
Okay.
Thank you very much, Alex. Are there any other questions or comments for Yusuf? In which case, thank you very much indeed. And our last presentation before our lunch break is from Zimbabwe, land registry using a distributed ledger.
Land registry using a distributed ledger. Land registry is a system responsible for land ownership registration. For one to secure the piece of land that they want to buy, they have to submit the official documents, the title deeds, at the land registry offices. So the land registry system that is being used now is a paper-based framework. It has got some challenges of time delays, and people may forge signatures, and some people may sell land that doesn't belong to them, with the claims that they own that piece of land. So it has resulted in many people becoming victims of fraud. And I'll also find out that in many countries like Indonesia, Zimbabwe, the system that is being used is a paper-based framework. And Sweden is one of the countries that is digitalized their land registry systems, and is the first country to pilot the property purchase via blockchain technology. Dubai is also in the process to digitalize their record into blockchain technology. Why the blockchain technology? The blockchain technology keeps the records immutable. Once the records are entered into the system, they are encrypted, they cannot be modified, they become permanent, therefore providing assurance at the authenticity of the recorded data. This will provide security and trust. So developing a system that automates and keeps records immutable is possible by implementing blockchain technology. Research objectives were to automate the land registry process, to record land ownership information using authentic certificates, to keep real-time transactions immutable, to search transactions promptly. The research approach used was the incremental methodology. It has got 4 stages. The first step is to gather requirements. So we went to the land registry and we observed how the process is being done, and we noted that it is a paper-based framework and other requirements that are needed for such a system, and also find out from research how a blockchain system is to be developed and the requirements of blockchain system. The second stage was to design. So the design was carried out in small interfaces to increase flexibility and to develop a land registry system that is innovative. Implementation and testing were done in a modular approach, since incremental methodology implies that the system will be built in small phases. So each module, the registration module, the education module, and the search module were implemented at the same time, tested as they were being developed. The technology description. The Hyperledger Fabric private blockchain was used for this study. There are 3 types of blockchain. There is a public blockchain that uses Ethereum framework. There's also a private blockchain that uses the Hyperledger Fabric framework, and the third one is both private and public, that is consortium. So for this project we use Hyperledger Fabric blockchain. The tools adopted were used for Hyperledger Fabric network configuration of smart contract development, front-end development, and the back-end development. Node.js was used for smart contract development, JSP was used for the front-end development, and Express for the back-end development. The development environment used was Visual Studio Code, as it supports one of the most important tools used, the IBM blockchain extension, as well as it is user-friendly. So this is the result from the list of transactions that we recorded in the system. We searched using the title did. We searched it using the title did. So after the search, this record came out. So the Hyperledger Fabric network was configured using an IBM blockchain extension as compared to manual configuration. Manual configuration requires a lot of time to be configured and a lot of obviously the IBM blockchain extension. Then benefits of using the blockchain system. Replacing the traditional pen and paper system of the land registry is supposed to calm fraud while making the process more trusty, more worthy of trust. Blockchain technology brings immutability, how the quality of a record not being modifiable once entered into the system. It also brings verifiability. All nodes in the blockchain network maintain the consensus version of the data on a block, meaning all the nodes in the network, in the blockchain network, will have the same version of the data. Once that data is recorded in the system, it will appear in each and every node in the network. Decentralization. This ensures a high degree of availability by eliminating a single point of failure. It also brings security, protect the system from hacking and other malpractices from intruders. In conclusion and recommendations, the land registry, system was targeted at using Hyperledger, Fabric, distributed ledger, private network by the City Council. The goal was to protect the modification of records by preserving the integrity of transactions and providing security and transparency. However, there is room of improvement achieved by increasing the number of nodes, sharing service algorithms, and doing user volume testing. Thank you. This is the end of my presentation.
Thank you very much, Nolwazi. Can you tell us a little about what you perceive as the challenges of using blockchain for these type of applications? So my understanding is that there has been some work in Ghana and Rwanda, for example, but are you aware of other countries where work on blockchain-based land registries has actually started? And what is the status for you at home?
Thank you. The challenges for using blockchain technology is that there is it depends what the type of blockchain that you'll be using, but it can give you a challenge of low scalability, or the other challenge that may arise is that maybe the people that are using the system might face challenges of maybe upgrading, since the technology is new, and the users may not be literate with or having the knowledge of how to maybe to upgrade such a system. So it might give them such challenges.
And can you comment on what the status is at home for you in Zim? You know, is there work on the ground actually evaluating whether or not that could be operational, or is this purely theoretical at this stage?
You may come again.
What is the potential adoption of such an approach in Zimbabwe? Has there been discussions with the government or with the Land Registry Agency about doing a pilot, or what is the stage of progress?
Okay, it is in the stage of discussion so that they can adopt it.
Okay.
There's also another system using blockchain that is also in the stage of discussion.
And what is that focused on?
Yeah.
This other platform that you're talking about, that's blockchain based, that's under discussion in Zimbabwe, what is that focused on? Is it on land registry issues as well, or another topic?
It's on it's another topic, but what I'm saying is that in Zimbabwe they are adopting. We are trying to adopt the blockchain technology in different domains.
Thank you very much. Does anybody else have any questions or comments? Because I think this is an area where there's a lot of confusion, and there's discussions about the advantages and disadvantages of public and private. And while there has been some work in countries like Sweden, for example, where they've taken a private-based approach, it would be interesting if, over the remaining parts of the conference, if people have insight in terms of what's happening in your country, you could share that as well, because I'm sure that Nolwazi would appreciate that insight to support her research. So is there any other questions or comments before we close the session? In which case, thank you to all of the presenters for interesting presentations. We're now taking a lunch break. So we're going to be starting again at 1:45 South African time. So that's in about an hour and 15 minutes. Thank you very much, everyone.
Thank you.